In this video, we're going to take a look at another special right triangle. We've already looked at the 45, 45, 90. Now we're going to look at the second one, and that's going to be our 30, 60, 90 triangle. So every 30, 60, 90 triangle is similar. Let me try again on drawing my triangle. So if this is 30 and this is 60, no matter how big or how small I draw my 30, 60, 90 triangle, the small one is going to be similar to the big one. And what that means is if I have similar triangles, there's a certain ratio of these sides, because in similar triangles, the ratio of your corresponding sides are proportional. So every single time there's some ratio from this side to this side and from this side to this side and so on. And the whole point of this activity was to try to discover that relationship. And if you have a protractor and if you have a ruler, please try this out. Pause the video, draw a 30, 60, 90 triangle, measure your sides, and let's see how close you can come to the actual ratio. I did this last year with my students, and I kept the results. And one student told me that directly across from their 30, when they drew their triangle, they had 7.2 centimeters. And when I asked them what was directly across from their 60, they said they had 13 centimeters. And across from their 90, they had 14.8. A second student in the class drew a much smaller one. They said, well, across from my 30-degree angle, I have 2.6 centimeter side. Across from my 60, I have a 4.6 centimeter side, and across from my 90, I have 5.4. And the third student that I asked, the third student said, across from my 30, I have 8.9 centimeters. Across from my 60, I have 15.5. And across from my 90, I have 17.9. So is there something happening between these numbers? So what I want to do is I'm going to just start with X being here across from my 30. So across from my 30, it has to be, well, it's not there. Across from my 30, that was across from my 60. Across from my 30 is some number X. From that point, can I use this X to calculate the one across from the 60 and across from the 90? All right. The first relationship that's the easiest is the relationship from here to here. When you see the number 7.2, what would you multiply that by to get to 14.8? When you see this number, 2.6, 2.6 times what would give you 5.4? 8.9 times what would give you 17.9? And, thinking of this using the inverse, what would you divide 17.9 by to get to 8.9, or 5.4 to get to 2.6? So if you're solving this problem here, let's set up a little mini equation. So let's take this number 2 right here. If I have 2.6 and I'm going to multiply it by something to get 5.4, what am I multiplying by? Well, I'm going to divide both sides by 2.6. And if I do 5.4 divided by 2.6, I get about 2.08. So my X here is 2.08. Now here, let's round it to the nearest tenth. 2.1. On this one right here with the 7.2, this one I calculated it earlier. It's 7.2 times about 2.05, and the 8.9, it's times about 2.01. So hopefully you see that we're real close to doubling, and that's actually the relationship. Whatever is across from your 30, double that, and you'll get what's across from your 90. going the other way around, whatever's across from your 90, cut that in half, and you'll get what's across from your 30. So no weird square roots of 2 here, nothing like that. Just double the number, and you'll have it. So for example, if across from your 30 is 10, across from your 90 is going to be exactly 20. If across from your 90 is 100, then across from your 30, cut that in half, would be 50. Now, the one that's a little bit more difficult is from here to here. What are we multiplying by to get from 8.9 to 15.5? And if we want to figure that out, let's just divide. Take 15.5 divided by 8.9. And if you do that division, you should get 1.7. What would you multiply 2.6 by to get 4.6? Divide 4.6 by 2.6 and you get about 1.77. What would you multiply 7.2 by to get 13? 13 divided by 7.2 is 1.8. So it looks like we're in that 1.7, 1.8 area. And this is the one that's the weird number. The actual value is that you're multiplying by the square root of 3. And the square root of 3 as a decimal is about 1.73. So as you can see, these students were very close to the actual value. So whatever is across from your 30, multiply that by the square root of 3, and you will have exactly what is across from your 60. So this right here is just the square root of 3 times the x value. So if across from my 30 is 10, across from my 60 is 10 times the square root of 3. If across from my 30 is 50, multiply that by the root of 3, then this is 50 root 3. And if you wanted to, you could type that in a calculator and get the decimal approximation. But those are your values. And the one thing that can be difficult is that you might not be able to start with the one across from the 30. Maybe they'll start with the one across from the 60 and say, hey, this is, I don't know, let's make up a number here. This is 25. Say this is 25 units right here. Well, then if I want to get to my one that's across from my 30, I'm going to have to divide by the square root of 3. And that's where you have to be comfortable with your working with radicals. So if I multiply by root 3 over root 3, this will be 25 root 3 over root 9. Root 9 is just 3. Sometimes this will reduce. In this case, it didn't. So you get a real ugly number here. This is 25 root 3 over 3. And actually, here, let me type that in my calculator real quick. I'll give you a decimal approximation of that. 25 times the square root of 3 is about 43.3. And then if we divide that by 3, we're about 14.4 on this number. So this is about 14.4. Now, to get to my 90, I want to double that. So if I take 25 root 3 over 3 and multiply that by 2, it's like multiplying by 2 over 1. You take the 25 times a 2, that's 50. You are not going to take root 3 times a 2 to turn into root 6 or anything like that. It's just going to be 50 root 3 over 3. And if we type that in our calculator, we should be at about 28.8. But here, I'll type it in real quick just to make sure. 50 times the square root of 3 gives me 86.6, and divide that by 3. And yeah, I'm at about 28.86. It's actually 20. There's a little bit of a rounding issue here. So it's not working out to be perfectly 28.8, but again, 28.9. So hopefully that relationship makes sense. Just to show you what it looks like in your textbook. So in every 30, 60, 90 triangle, this is a 30, 60, 90 triangle theorem, the hypotenuse is twice as long as the shorter leg. So across from my 30 is my shorter leg, and across from my 60 is, I guess, my medium-sized leg. And the longer leg is root 3 times as long as the shorter leg. So these are your legs of your triangle, and this is your hypotenuse here. So whatever value x this is, double that. That's across your 90. That's 2x. and from here to here multiply by the square root of 3, and that's what's across from your 60. Just to show you this one more time, and if you're taking like the SATs or something, you have a reference sheet they'll give you, and I don't remember what exactly it looks like, but they could give you this as well, because this kind of means the same idea. Instead of calling it across from my 30x, just call that a unit of 1. So for every 1 unit that is across from my 30, double that, and I have 2 units across from my 90, and across from my 60, for every 1 unit that I have across from my 30, multiply by the square root of 3, and I have root 3 units across from my 60. So in a triangle whose angles have the measures 30, 60, and 90, the lengths of the sides opposite these angles can be represented by x root 3, and 2x respectively.